In this tutorial, we're going to use Cramer's rule to solve a system of linear equations with three variables. So let's say we have 2x plus y minus z, and that's equal to 1. And also 3x plus 2y plus 2z, and that's going to be equal to 13. And then 4x minus 2y plus 3z, let's say that's equal to 9. Now, this equation is in this form. So it's a1x plus b1y plus c1z, and that's equal to d1. And then we have a2x plus b2y plus c2z is equal to d2. And then a3x plus b3y plus c3z is equal to d3. So the letters A, B, C, and D represents the coefficients in this equation. And the subscripts 1, 2, 3 tells us the row that we're dealing with. So subscript 1 is for the first row. Subscript 3 is for the third row. Now x is equal to dx divided by d. Y is dy over d. And z is dz divided by d. So we need to calculate dx, dy, dz, and d. And then we can get the solution to these equations. So let's start with d. D is going to be a 3 by 3 determinant. And the elements in this matrix is going to be a1, a2, a3. So those are the coefficients for the x variables. And then b1, b2, b3. So those are the coefficients for the y variables. And then c1, c2, c3. So you need to know how to evaluate a 3 by 3 determinant. So first, let's start with a1. If we eliminate row 1 and column 1, we'll be left with this. So it's going to be a1 multiplied by a 2 by 2 matrix, or the determinant of a 2 by 2 matrix rather, b2, b3, c2, c3. And then it's going to be minus the next one, which is b1, and we need to eliminate row 1, column 2, because that's where b1 is located, in row 1, column 2. And so we're going to have a2, a3, and c2, c3 left over. And then it's going to be plus c1, and c1 is located in row 1, column 3. So we're going to get this. a2, a3, b2, b3. So that's how you can evaluate a 3 by 3 determinant. So in this example, a1 is 2, and then b2 matches with 2, so b2 is 2, b3 is negative 2, c2 is 2, and c3 is 3. And then minus b1, b1 is 1, is the coefficient in front of y. And then a2 is 3, a3 is 4, c2 is 2, and c3 is 3. And then plus c1, which is negative 1. So c1 is in front of z, that's negative 1. And then a2, that's 3, a3 is 4, b2 is 2, b3 is negative 2. So now let's find the determinant of a 2 by 2 matrix. So it's going to be 2 times 3, and then minus 2 times negative 2. And we still have a 2 in front of that. This is going to be 3 times 3, which is 9, minus 2 times 4, which is 8. And this is going to be 3 times negative 2, which is negative 6, minus 2 times 4, which is 8. Now, 2 times 3 is 6. Negative 2 times negative 2 is positive 4. And 9 minus 8 is 1. Negative 6 minus 8 is negative 14. 6 plus 4 is 10 times 2 is 20. And negative 14, that's positive 14. So we have 20 plus 14, which is 34, minus 1, that's 33. So D is equal to 33. Now let's calculate dx. So for the elements in dx, replace the coefficients in front of x with d1, d2, d3. So it's going to be d1, d2, d3, and then b1, b2, b3, and c1, c2, c3. So d1 is 1, d2 is 13, and that's 9. And then for the b's, those are the coefficients in front of y. And then c1, c2, c3, those are the coefficients for z. So we're going to start with this number. It's going to be 1. And if we take out the row and column that correspond to that number, we're going to get these numbers. So that's 2, 2, negative 2, and 3. And then it's going to be minus the second one, which is also 1. And then that element corresponds to row 1, column 2, leaving behind these 4 elements. So it's going to be 13, 9, 2, 3, and then plus this one, which is negative 1. And that corresponds to row 1, column 3, which leaves behind 13, 2, 9, and negative 2. So this is going to be 1 times 2 minus 3 is 6, and then minus 2 times negative 2, which is negative 4. And then it's going to be 13 times 3, which is 39, minus 2 times 9, which is 18. And then 13 times negative 2, that's negative 26, minus 2 times 9, which is 18. So 6 minus negative 4 is 6 plus 4, which is 10. 39 minus 18 is 21, with a negative 1 in front of it, so that's negative 21. Negative 26 minus 18, that's going to be negative 44. Times negative 1, so that's positive 44. So we have 10 plus 44, which is 54, minus 21, which is 33. So dx is equal to 33. Now, let's focus on dy. So this time, the coefficients in front of y, we're going to replace it with d1, d2, and d3. So it's going to be a1, a2, a3, and then d1, d2, d3, and then c1, c2, c3. So this corresponds to the numbers 2, 3, 4, 1, 13, 9, and negative 1, 2, and 3. So let's start with this number 2. So that's in row 1, column 1. So it leaves behind 13, 2, 9, 3. And then minus the next number, which is 1. And that's located in row 1, column 2. So it leaves behind 3, 2, 4, 3. And then it's going to be plus negative 1, and that's in row 1, column 3. So that's going to be 3, 13, 4, 9. So this is going to be 2, and then 13 times 3 is 39, minus 2 times 9, which is 18, and then 3 and 3 is 9, 2 and 4 is 8, 3 times 9 is 27, 13 times 4 is 52. Now, 39 minus 18 is 21, 9 minus 8 is 1, 27 minus 52, that's negative 25. 2 times 21 is 42, and 42 minus 1 is 41. 41 plus 25 is 66. So dy is 66. Now, let's move on to the last one, dz. So in this case, the coefficients of z will be replaced with d1, d2, and d3. So it's going to be a1, a2, a3, b1, b2, b3, and then d1, d2, d3. So we're going to have the numbers 2, 3, 4, 1, 2, negative 2, and 1, 13, 9. So let's start with this one, 2. So if we eliminate row 1, column 1, we're going to have 2, 13, negative 2, 9. And then minus the next number, which is 1. And then if we eliminate row 1, column 2, we'll have 3, 13, 4, 9. And then it's going to be plus 1. So let's eliminate row 1, column 3, and that's going to be 3, 2, 4, negative 2. So this is going to equal 2, and then 2 times 9 is 18, and then minus negative 2 times 13, that's negative 26. And then minus 1, 3 times 9 is 27, 13 times 4 is 52. And then 3 times negative 2 is negative 6, 2 times 4 is 8. Now 18 plus 26, that's 44. 27 minus 52 is negative 25. And negative 6 minus 8 is negative 14. Two times 44 is 88. Negative 1 times negative 25, positive 25. Now, 25 minus 14 is 11, and 88 plus 11 is 99. So dz is 99. Now we have everything that we need to finish the problem. So x is equal to dx over d. And that's going to be 33 divided by 33, which is 1. So that means that x is equal to 1. Y is dy over d, and that's going to be 66 divided by 33, which is 2. And y is equal to 2. And then z is going to be dz over d, so that's 99 divided by 33, which is 3. So z is equal to 3. So the solution is 1, 2, 3 in the form of x, y, z. And that's it. So now you know how to use Cramer's rule to solve a system of equations with 3 variables.